More than 500 drowning deaths in just 1 year. At least 504 persons died in drowning accidents according to the DLRG in 2018. That is the German Association for Lifeguards. And that's 100 more than in 2017. One reason is the good weather. Good weather means more people are swimming, more people are drowning, right? This was reported in the 2019, one of the editions in Der Spiegel, a respected German magazine. So the question is, the increase from 400 to 504, roughly a 25% increase, is partially due to good weather, but it also corresponds to 100 persons, and people matter, right? So it's a tiny fraction relative to the population of Germany, though. Well, is this a problem in the sense that we have to do something about it? Is this a problem, yes or no, or we can't decide? Usually I ask this question twice when we're not online, but given that we are online, I will show you the next slide where I put this data a bit more into context and look at previous years. You see, in 2018, we had this value 504. In 2017, we had roughly 400. But then we see in 2016, we had an even larger value and we had other values here, right? So we get a bit of an idea of the variation. Now, in light of this, a problem, not a problem, or not enough information? All right, I will leave you to answer that. The material we cover in this course, on part of the course on process control, is mathematically less complex than regression. And there is a tendency of some to consider material that is mathematically less complex as obvious or too easy. But that's not the point. The point is to solve problems. The point is not to be mathematically complicated for the sake of being complicated. Very, very often, statistical thinking is far more important than fancy modeling. And so we are now in a section of the course where it's not going to go very fancy, but we do have to think about what we're doing. All right. So the drowning death can be seen as a process. Right? These are deaths over time, and they are affected by randomness. And our goal here is to assess the process, to measure it, to find out whether it's out of control. That's a key word, out of control. Out of control means it shifts upwards or downwards or something. And to look for ways for how to improve it. Now, looking for ways for how to improve it is great fun. And it is in this point where we are limited, because we can't go to the factory floor and say, well, we've noticed there's this following trend here and the process is getting out of control. And can we see what happened on that day, or can we see what changed? Well, because we don't have a factory floor, right? So we have to look at it a little bit from the outside. But that is an essential part of the answering the problem. Okay, so what we did here in this example of the drowning death was to compare, or what Spiegel did, the magazine, was to compare the current value for the current year to the value from the last year, and then saying, oh, it's 100 more, and oh, that's 25% more, and oh, that's a problem. And this is actually quite common in a manufacturing plant. Managers sometimes sit together and discuss what went wrong the previous day. That's not necessarily a bad thing, but you can't just look at this previous day and see that out of the context of what happened in the previous 4 weeks. Because just looking at the previous day doesn't give you an idea of the variability, because two observations don't make a trend. Muggles often find patterns in random noise. We have seen that a little bit when we talked about the diagnostic plots in regression, right? It is so easy to see an interesting pattern in there, or some weird shape in there. And if you take out a couple observations, all of a sudden the shape is gone and it's really nothing. Muggles, by the way, I'm using that word from the Harry Potter book series. A muggle is an ordinary human without magical abilities. So in this sense, a person who is not used to random noise and can deal with it. When you look at a graph and it is very tempting to find a reason why each point shifted up and down. And the idea that there's maybe no reason, that it's just random variation, is actually something that's difficult. And it's easy to say, but when you see something, you're very much tempted to attribute something. I remember there was a tale, a data analyst had given a professor, not in statistics, but in, I forget what it was, in some applied subject matter field, an analysis. And they had this wonderful discussion about it, what it all meant. And the professor had all the explanations. And then the data analyst found a mistake in his calculations, and the values were quite a bit wrong because of, computing mistake. And then he or she was very much concerned, but they told the professor the next time they met, and the professor just went on and said, "Oh yeah, this makes sense," and he had a whole other sense of explanation. It is very, very easy to come up with a whole set of explanations. It's hard to believe in randomness as an explanation. Okay, so another common fault or a variation on the theme is to compare the current value not to the previous one, but to the average. For the accidental drownings in Germany, the average number of accidental drownings in that 10-year period was 446. In 2018, it was 504. But we know that roughly half the values are above the average and roughly half the values are below the average. A one-time below average performance is nothing we want to be concerned about. Okay, I'll leave you with this. This is the end of this segment.